Hi, today we're just going to take a quick few minutes to review some of the things that we've learned about the unit circle now that we put all the pieces together. So we covered a lot last class, so this is just kind of a rehash. So on the first two things, there's two things on your notes. It says count by pi over 6. So the pink marks are the pi over 4, the 45-degree markers. So this would be me counting around by pi over 6 is, remember, I'd start at 0 and then I'd end at pi over 2. So 0, pi over 6, pi over 3. All of the ones that are pi over 3s are those that simplified and would be equivalent to pi over 6. So remember, when you're doing this, if you're trying to sort things out or just mental note as you're working through problems, remember that if you have to convert back, if you have pi over 3, that's the same thing as 60 degrees, and if you have pi over 6, that's the same thing as 30 degrees. Okay, moving on to the second one where we counted around by pi over 4s. There's a pi over 4 halfway through every quadrant. So 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 2 pi over 4 is where we end because that's what all of those would simplify to. All right, the next thing on the agenda is looking at the special triangles one more time. And so when we talked about this last class period, we said we learned that the general side ratio for any 45-degree triangle is x, x, x root 2. That's what you learned in geometry. And then you looked at a specific special right triangle where the legs were 1 and that left the hypotenuse to be root 2. The unit circle takes this special right triangle and adjusts it because remember we said that a unit circle has a triangle where the hypotenuse is the radius and the radius length is 1 unit. So I had to divide all the sides by root 2 to simplify that down to get a radius of 1. And that left me with the side measurement of root 2 over 2 and root 2 over 2. If I'm looking at my basic 30, 60, 90, the patterns or the ratios here were x and 2x for the hypotenuse and x root 3 for the next longest side. And then your special right triangles that you learned about in geometry had a short length of 1 that left the next longest leg root 3 and finally the hypotenuse 2. And so then when we turn this into a triangle we could use on the unit circle, again it's a triangle where the hypotenuse is the radius of the circle and the radius length is 1. So to get rid of the 2 and make it a 1, I had to divide all the sides by 2. And that left me with 1, 1/2, and root 3 over 2. So those are my special right triangles. The next question is asking you to remember where things are positive and negative. So we use that saying all students take calculus. So in this quadrant, sine and cosecant are positive in quadrants 1 and 2 and negative in 3 and 4. Cosine and secant are positive in 1 and 4 but negative in 2 and 3. And tangent is positive in 1 and 3 but negative in 2 and 4. So then the next one asks you to recreate a unit circle. So when I say recreate, I want everything in there, all of your identifications, the degrees, the radians, and the coordinate point. So you may have used different space for that, but I did manage to make it fit. And then again, just reminding you, these are the identities that we used to kind of calculate some of those values, and that the point xy on the unit circle is cosine theta sine theta. And then finally, the last part is reviewing the triangle itself. So I have my triangle here with length x, y, and r. So think about like if it's on a circle, which means this is the hypotenuse, this is the opposite, and this is the adjacent from theta, which is at the origin. So the first thing I did was just the basic definition. So sine of theta is opposite over hypotenuse. Then in this particular triangle, that means y over r. And then in this ratio right here, if r equals 1, which is that hypotenuse length, then sine of theta equals y. So you can kind of see how we get from sine to y. In this one, cosine is adjacent over hypotenuse. So in this triangle, that's x over r. And if in this triangle the radius is 1, then that leaves me with x. Okay? Tangent is opposite over adjacent. And then in this triangle, that leaves me with y over x. And then I go down here to cosecant. In this triangle, that would be hypotenuse over opposite, which means in the triangle it's r over y. And then if r equals 1, we would just get 1 over y. On secant of theta, the ratio is hypotenuse over adjacent. In this particular triangle, that's r over x. And if r is 1 in this particular triangle, if the radius is 1, then we get 1 over x. And finally, cotangent. So the ratio of cotangent is adjacent over opposite. And then in this particular triangle, adjacent over opposite means x over y. And so you can kind of see how those ratios develop. So this was just a quick review of everything that we've been working on in unit circles. We are going to do the worksheet 46 review today, which covers reviewing lots and lots of things that we've covered in trig, and in the hopes that we're going to use these next few days to get ready for our test. Thanks so much, guys. Bye.